Good afternoon. We resume again our lecture series on Six Sigma. We have two sessions planned this afternoon for you. The first is going to be a journey. So we're going to recapitulate some of the material that we've been discussing so far. That will be like the first part of the 2-hour session. And the second half, I'll try to illustrate the methodology using a case study, a live case study that was conducted under the DMAIC framework. This is what we'll be doing. Starting out, we obviously have we will be doing the quick recollection first, and then of course the Six Sigma case study is going to follow from that. Let's try to recapitulate. Let's try to recall what exactly is Six Sigma. It's a method to improve business processes. And this is done by constantly reviewing and updating and also retuning processes which are there. These could be existing processes or in need of improvement and so on and so forth. So that's what provides the motivation for doing this. What does Six Sigma achieve? First of all, it will improve process improvement. Process performance is going to be improved by Six Sigma. It's going to decrease variation. It's also going to help maintain consistent quality of the output. These are some of the accomplishments of Six Sigma when you complete the project successfully. This effort is going to reduce defects and also improve profits in the end because there will be fewer losses. It's going to raise employee morale because they'll be working with a process that has got good quality coming out of the system. So product quality would be impacted, and finally, of course, customer satisfaction is going to go up. These are some of the benefits of Six Sigma. Six Sigma actually strives for perfection. It allows only 3 or 4 defects per million opportunities where you could make a mistake, where you could make an error. It tries to minimize that. It tries to bring it down to the level of 3 or 4 parts per million opportunities. And of course, to be able to do that, it relies very heavily on statistical methods. In particular, design of experiment. That's like something it cannot really do without. It's a proven method now. It's been proven many times, and Motorola saved billions of dollars, something in the order of 17 or 18 billion dollars Motorola ended up saving once they adopted this Six Sigma approach. It's a disciplined approach. It's an application of statistical problem solving tools in a disciplined way. It identifies and helps to quantify wastes also. If there are wastes in the process, if there are wastes in the as a byproduct of the process itself, it tries to minimize that. It tries to basically reduce them to zero. It also indicates steps for improvements are required. That is done by the process. As the process moves along, as you move along the Six Sigma path, you look at many opportunities where improvements could be made. Savings are actually possible because many natural processes, many processes that have not been worked upon, those actually demonstrate high variation in their output, and that actually gives us the opportunity to be able to do that. If you, for example, if you look at a process that is an existing process, most companies today, they are operating around 3 or 4 sigma by the sigma metric. So in fact, there is a large opportunity to go from there to the Six Sigma level. There is a large opportunity there. The gap is pretty wide, which really means that a lot of customers who are not satisfied with the products we provide or the services that we provide them. They are really not satisfied. If you look at the process, the Six Sigma approach is pretty much synonymous with the DMAIC model. And DMAIC, as we are going to be discussing in this session here, and we've already done that in the past, it comprises 5 steps. You define the issue, you define the quality issue that is there. You measure the extent of that performance. You try to find out what current performance is. Then you go through an analysis, which is the analysis step of DMAIC. And once you've done the analysis, you identify certain actions which might move the process toward an improved state, and that would be done under the step called improve in DMAIC. And this is where you'll be utilizing statistical methods such as, for example, design of experiments. That could be one of the methods you'll be using. There could be many other methods also that you utilize. Quite often, actually, if you start recording data and if you start plotting the data and so on and so forth, a lot of problems become visible. Let's say you've come up with a process which is one that is nowhere near the Six Sigma level of operation. is probably near 2 sigma or 3 sigma. You'll find it quite easy, in fact, to do some trials and tests and so on, provided you use the framework of DMAIC, that you achieve an improvement. And that's going to be really the new level of performance. Once you identify that, your job is going to be to control the process to keep there. So in fact, the 5 steps are going to be define, measure, analyze, improve, and then control. This is what DMAIC comprises. And that process has become, that method actually has become synonymous with any Six Sigma program that people talk about. What is the goal of Six Sigma? The goals are pretty straightforward. Six Sigma basically aims at reducing defects and losses, and it tries to cut cost, and thereby it tries to improve profits. In fact, the starting point really is to try to find out what the CTQs are. What are those quality characteristics that customers would like to have? This is something that is the starting point of a Six Sigma program or a Six Sigma project. Then the second thing is to try to understand factors that impact the CTQs. This is something that you'd like to identify because you'd like to have some actions to follow through the project. If you've found out what the problem is and if you've found out its reasons, its causes, then of course you get something to act on. And that's going to be one of your steps. Control now, you'll try to control the vital few factors that have the largest impact on the CTQs, those characteristics that are critical to quality as far as the customer is concerned. To be able to do these things, of course, you need some personal quality, and these are required by members of the team, members of the Six Sigma team who really take care of the project. You've got to have tenacity. You should not give up. You should have mental toughness. There will be many situations that will be tough for you to handle. You must have that toughness to be able to go through it. And of course, you must have unwavering dedication to pursue perfection. In fact, this is something that you really require. You must seek perfection at almost any cost. That is something, if you show that drive there, there's going to be opportunities when you might actually have second thoughts and so on and so forth, but stick by it and you'll end up delivering the what we call a better process. Where would you start? The starting point is going to be by focusing on business metrics. Now, I should just recall here, remember the old method for managing quality was to do TQM, Total Quality Management. And there are 5 pillars on which TQM was founded. Top management's direct involvement, that like came even without saying. Unless top management drove quality or the mission to try to satisfy customers, it just won't happen. The second thing was strong customer orientation. That was the second facet of Total Quality Management, TQM. The third was applying statistical methods. When you have problems, your action should be data driven. And the science for handling data is basically statistics. So that's why the methods that you'll be utilizing as per the recommendation of TQM is statistical method. The fourth item is going to be everyone will participate. This is also something that is required. You can't just say that the quality control department or the production department, they are going to be in charge of quality. Nobody has anything to do with it. That's certainly not true if you assume TQM to be guiding your company. And the fifth and the last one is continuous improvement. They're the 5 pillars. They are the 5 pillars of total quality management. What is missing, unfortunately, in this, and that's why many people had second thoughts when they launched TQM program, they did all the training and everything, and results were not there. The problem with TQM is it does not really show any incentives for making an improvement. There are no dollar incentives as the bottom line of total quality management. It's to be taken on faith because it works. If you ask people, why should I do TQM? They'll probably end up responding because it works, because it has an impact on quality. But unfortunately, that dollar or the money part or the incentive or the bottom line or return on investment, none of these financial considerations are there when people talk TQM. The result is this. This was actually when people had, management in particular, wanted to get something on which they could hold on to. And that was actually if they had a project that showed an ROI in the end. So this was like one of the key things that was utilized, that was incorporated in Six Sigma projects. No Six Sigma project can be launched unless the project can project to achieve a certain level of ROI for the investments and for the resources that's expending on that improvement project. So every Six Sigma improvement project must produce an ROI. Without that, you can't really justify any activity. It's not going to be any different from your general management of quality. So Six Sigma is quite distinct that way. It must be able to project that I'm going to be producing so much of ROI. The next thing is you've got to start with customers, find out what these critical to quality factors are, what these CTQs are. That's going to be very important. You've got to be able to measure them. And the ultimate goal of Six Sigma, of course, is to measure your performance on this universal metric called DPMO, or defects per million opportunities. Six Sigma reaches the level of 3 or 4 parts per million. If you've done it right, you'll end up with a process that's very consistent, and it will produce defects which are like products that are not acceptable to customers only to the extent of 3 or 4 parts per million parts. Another metric that is also utilized in Six Sigma, particularly when you're looking for a project, is to look at your data on cost of poor quality. And there, of course, there are 4 components of that. There is the appraisal cost in cost of quality. Then there are the external failure costs in cost of quality, and this we've covered in the earlier lectures. Then you've got the internal failure cost, which will comprise scrap, rework, those sort of things. And the last one that really pays is prevention cost. If you increase prevention cost, that's like taking proactive actions. That's like assuring quality. And with that, your appraisal is going to come down, appraisal cost is going to come down, external failure cost is going to come down, internal failure cost is going to come down. So it's not that all costs of quality are bad. Prevention costs in particular are quite good. In fact, they produce the ROI. The prevention costs, they often get into Six Sigma programs, and they are the ones that really help you produce the returns that you're looking for from a project. So as far as cost of poor quality is concerned, you could look at the external inspection that is going on, the amount of rework that is going on, the amount of scrap that is going on, losses caused to customers that is existing right now, non-value added work. These are the roots for losses in the company. These are various examples of the cost of poor quality. These would give you places to look at whereby you can justify a Six Sigma project. So in fact, the focus is going to be then business metrics. Six Sigma exists in 3 avatars. There are 3 incarnations of Six Sigma. And the first one, of course, is the metric. Six Sigma is a metric. A metric is any type of measurement that is used to gauge some performance, some quantifiable component of the company's performance. That's like something that a metric would indicate. The second thing that also is synonymous with the Six Sigma is the DMAIC methodology. So methodologies are also kind of unique in Six Sigma. And Six Sigma does provide a unique body of practices and procedures and rules. These are cloaked under this DMAIC procedure. Then, of course, the third thing that Six Sigma also brings forth is a management system, which is a proven framework for managing and continually improving your performances. These could be actuated through policies, procedures, and of course the processes that you run. So in fact, having a metric, having special methods, and having a management system, these are going to be basically the arms and ammunition for Six Sigma. Essentially, Six Sigma does all 3 of these at the same time. You won't be able to say, I'm now doing management, or I'm doing DMAIC, or I'm measuring performance. It's all being done together in a Six Sigma project. The term Six Sigma itself, if you look at the way it is done, Six Sigma, this particular thing, it actually is a registered service mark and a trademark of Motorola Company. Motorola Company were the first people who coined this phrase Six Sigma. And as you saw in the earlier part of the thing, Motorola, they were the pioneers. Of course, many people followed from there. The reason is that it produced results. It produced good results for them. Let's take a closer look at what I meant by these 3 different things. What is Six Sigma as a metric? It's a way to measure your performance. So in fact, Six Sigma equals 3.4 defects per 1 million opportunities. That's a metric. In fact, it may turn out that your level of defect is not quite at this level. Then your Sigma measure is going to be less than Six Sigma. It's going to be maybe 5 Sigma, or 4 Sigma, or 3 Sigma. It could even be 2 or 1 Sigma. If your process is very poor, and I'll show you later what it really means to have a Six Sigma program as opposed to a Six Sigma process, as opposed to a Three Sigma process. I'll show that to you. You'll see right away a Three Sigma process is pretty wide. It has a lot of variability. And a Six Sigma process is pretty narrow. It's pretty tight. It's well within what we call the specification limits. Specification limits which are acceptable to the customer. Any product inside is acceptable to the customer. And this is quite different from a process which has got tails that are coming out of the spec limits, and it's got a lot of losses there. Let's take a look at the second way of looking at this thing. I have a display here of various types of systems. I have various types of systems which exist around us today. We've got, of course, the best in class, and these are near the Six Sigma level. The best in class, these are near the Six Sigma level. For example, airplanes landing. You hardly have any fatality. That's not a routine thing. You may have a few per million landings or takeoffs, but there are some incidents. In between, you've got a process which is like at 4 sigma level. Sigma is the metric which is like superior when you're near 6 or 7 sigma level. That's a tag given to the process. And it's certainly inferior if you're down to the level when you've got only 2 sigma. The process qualifier for a process is only 2 sigma or perhaps 3 sigma. Now, in between, which is near 4 sigma, you've got things like airline baggage handling. That's got a few mistakes going on every day. And then you've got restaurant bills, errors on restaurant bills, errors with doctor's prescriptions, errors in payroll processing and writing up orders and joint vouchers and wire transfers and so on. If you look at these things, these are at the 4 sigma level. The error level there are a few parts per thousand. That's the common experience today. And these are certainly then not near the 6 sigma level. They are at 4 sigma level. If you come down, for example, if you look at the system where in the IRS office there are people who answer some questions. If you give them a call, it's almost like a call center, except that these people are supposed to be advisors. They are supposed to be knowledgeable about the different tax laws and so on and so forth. If you ask them a question, there are pretty big chances. There may be about 1 chance in 20 or 1 chance in 30 or 1 chance in 100 that their answer is going to be wrong. And that's going to be at the 2 sigma level. So in fact, over here I've got, if you go from the left to right, I've got very inferior systems that have a lot of defects in them. We've got intermediate systems like airline baggage handling that's got a few mistakes per thousand, for example. Then of course, I've got, of course, the parts per million type of systems which are out here on the right hand side, like such as aircraft landing or babies being taken care of in a hospital and so on. There are very few fatalities there. Those are at parts per million level. And in fact, the strive is to take a process which is around here, take a process which is to the left, and slowly through statistical methods and experiments, and by applying the DMAIC process to try to push them toward this side. This is what we'll be doing. This is what we are reviewing right now in this lecture. We're going to be seeing how we can take a process which is not so good and gradually move it towards 6 sigma. We'll walk through the process. 6 sigma is a methodology. It's a business process improvement methodology. It's a process improvement methodology. And what it really does is, it really requires managing customer requirements. It starts, of course, with understanding customer requirements. That's very, very important. Then aligning the key business processes, the ones that deliver those products or services to the customer. What we'd like to be able to do is, we'd like to be able to control and align those processes so that we get the delivery the way we expect it to go out to the customer, for example. We would also like to make sure that the method utilizes rigorous data analysis procedures. In fact, in particular, it uses design of experiments. That is used in the DMAIC process. It is used at the improvement stage. We use design of experiments. And of course, we'd like to be able to deliver rapid and sustainable improvement. This is something that we'd like to be able to deliver. All these characteristics, they exist with the Six Sigma process, with the DMAIC process. So the methodology, it's a business improvement process. That's what this is. This method is rigorous, and I said there are these 5 steps. Define the opportunity, measure performance as it exists today, analyze the opportunity, improve the performance by using whatever means it takes. It would involve, in many cases, conducting DOE, designed experiments. And then, of course, once you've established the optimum levels for these different factors, you got to make sure that process variables stay at that level. That is called control. And this could utilize SPC, for example. Six Sigma is also a management system. Now, what exactly is a management system? It's a top-down solution. It's a top-down solution. It is driven by top management. And it begins with aligning the business strategy to critical improvement efforts. That's like something that has to be done. So, moving towards Six Sigma really is a strategic move. That's something we've got to remember. It has a long-term impact on the company's projects and processes and everything else. It mobilizes teams. There are teams who are given a certain charter, then they'll define the scope of it, then they'll get into the work breakdown structure, then they'll work out the details of the planning. And this is run project by project by project. All Six Sigma undertakings are really projectized and they are delivered with a certain ROI. Each of them is justified with a certain ROI. And in the end, when you've completed the project, you take a look at the output and then you try to sort of see, have I delivered that? Have I actually ended up delivering that? That's a post-audit that you've got to do when you end up with the Six Sigma project. And of course, the management system will govern the total effort. It will make sure that the improvement that you achieve, that you suggest that yes, they can be delivered, those are sustained in future. It turns out that this management system provides a framework. This framework will help people prioritize resources for projects that will be improving the metrics, the different performance measures. It also leverages leaders. These are the people who have special expertise, and I'm going to be talking about them in a couple of minutes. Those are going to be the master black belt people. First of all, the champions are the master black belts, then the standard black belts, then the green belts. These are the people who are going to be basically taking care of the actual Six Sigma project. Those would be there. How did it all begin? Let me try to recall this for you. We did that some weeks back. The phrase was coined by Motorola, and the gentleman who did this had a pretty simple name, William Smith. He's the one who was an engineer at Motorola, and he designed this approach and so on and so forth. And of course, they chose this very catchy name, catchy tag of Six Sigma, which is a level of perfection that talks about parts per millions only in terms of defects. Now, of course, Six Sigma is a major influence on production methods and quality assurance worldwide. Most of the leading companies, they go by the Six Sigma way. They actually are going this way. Many are still getting off the ground, they're doing their training and so forth, but the ones that are leading the pack, they actually have Six Sigma in place. The method itself is data driven, and the science that helps you handle data is statistics. So many methods utilized, many techniques utilized, they are taken from statistics. And the idea is to try to improve processes and reduce variations in quality. So if you've got a wide variation, you'd like to tighten it. That's moving towards Six Sigma. You start with a process that's pretty bad, that's got a lot of defects being produced in the fringes. You try to compress it. And this should be doing by compressing the sigma that is there, the sigma of the process. And I'll be showing that. As I show you the pictures, you'll be able to see how this is done. But Six Sigma also demands organizational change, a lot of training, and a good bit of planning. All these are required by Six Sigma. Now, what about this zero defect phrase that we heard some time back? The zero defect actually is a target. It's something that's like that was the quality gurus, they ended up setting this high enough goal and they called it zero defect, and they actually said quality is free. If you produce everything defect free, then quality is free. If the product and the output is defect free, then quality actually is free, because you do not have those losses, those various losses that go with imperfect production and defects and so on and so forth. Six Sigma actually does not really lead to zero defects, but it does lead to near zero defect, because you're talking about defect levels, which are now parts per million. People who bought this idea early on, they were Bank of America, Caterpillar, Honeywell, and Raytheon and Merrill Lynch and so on and so forth. Many of them, they adopted this approach and they ended up improving their process. And I don't have to tell you about General Electric. Jack Welch, one of the biggest champions of Six Sigma. In fact, he went around telling people, unless you are a black belt, your position in the company is frozen, and perhaps you'll be asked to go out. That's also is actually quite possible. And this was actually true for Jack Welch. He himself got trained and made sure almost everyone in the company understood what he meant by Six Sigma, what the company General Electric meant by Six Sigma. How does Six Sigma use statistics? Let me start with a very simple example here. If you look at this curve there, many of you will recognize this is a normal distribution curve. And this normal distribution curve has two parameters. One is, of course, the mu, which is the process average. Then the other parameter that this curve has is the sigma. Sigma is your standard deviation. So I have my process, and hopefully the target is close to where the process average is, which is like mu is sitting right on where the target should be. A Six Sigma process is so tight that from the midpoint, if you try to take a look at where the upper specification limit is or where the lower specification limit is, it is 6 sigma distance away. It's quite a bit away from here. Now, you know the general distribution of almost all of the items which have this distribution of mu being the mean and sigma square being the variance of it. Most of the production is going to be confined in this area. Almost all of it will be confined in this area. Now, if I put a mark there, if I put a barrier, if I put a limit there, which is 6 sigma away from here, you can understand that whatever trickles beyond this, that is the tail of this little curve here and the tail of this little curve here, those tails are going to have almost a few parts per million when they come out beyond this specification limit. That's actually how we are visualizing. We have a statistical view of this process now. So the process itself has a variation. The process itself has a variation which is plus minus 3 sigma. But the spec limits are far out here and far out here. They are farther away from the ends of the process. The ends of the process are 3 sigma up and 3 sigma down. If I put away the spec limits, if my process has been made so tight, it has been made so precise that products come out pretty close to where the target is. They vary only by plus minus 3 sigma, sigma being the standard deviation of the process that you've got in action. If the spec limits now are 6 sigma away from the midpoint this way and 6 sigma away from the midpoint this way, you hardly have anything that could be called a defective item coming out of this process, coming out of the process which is here in the middle. So basically, the principle of 6 sigma is reducing variation. This is what we would like to be able to do. And we are using sigma as the measure. And what we'd like to be able to do is center the process and keep it so tight, make it so precise that the midpoint is 6 sigma away from either end of the spec limits. That's what we should be able to do. Our results, that's where our focus should be. Our focus should be on the results. And in fact, every Six Sigma project must focus on results, nothing else. It must focus on results. What is going to be the output? What was the output before? What is the output now? And after I adjust the process, after I improve it, what is going to be the output? I've got to keep an eye on the output itself. That's like something I should be able to do. I must have very good communication. People should understand within the company and certainly within the team. They should understand when I'm talking sigma and so on and so forth. When I'm talking design of experiments, optimization, they should understand what is going on. When I'm talking CTQ, people should understand what is going on. Also, there should be the commitment to achieve perfection. That also is something that must come alongside the thing. Now, who are the people who are culturally oriented toward this? And these are the black belt people. The black belts, these are specially trained people. They know a lot of statistics. They know all these statistical techniques and so on and so forth. They are the ones who lead Six Sigma projects full time. That's their job. Then, of course, you've got master black belts. Master black belts are really, they are the supports. They train black belts in turn. Then, of course, other people are there in the team. They are called the green belts. They also know plenty of statistics. They are the ones who carry out a lot of the detailed work that is there, that are guided by the black belt people. So, you've got the master black belt, then you've got the black belts, then you've got the green belts. This is the full team. And of course, overriding all of these people, there is a champion. There is a champion for the project itself. Then, of course, is the process owner, someone who is interested in the output coming out of the process. That's also someone who is going to be part of the thing. They all put their focus on results. Let's quickly take a look at what are the characteristics of some of these people that we just mentioned. The master black belts, they are like the top-notch people. They do most of their time, they do consulting and monitoring, and they do training. And they spend almost all of their time in doing just that. And they should be able to mentor 5-6 black belts at any time. And they guide or they stay involved with about 10 Six Sigma projects per year. Then you've got black belt people, and they are the ones who really are highly competent technically. They are actually master black belts, of course, have been black belts before. The black belt themselves, the lead use of the techniques, and they communicate the new ones, communicate new techniques to the team. They spend 5 to 10% of their time consulting or training, and most of the time they are leading the details of the project itself. And they might be mentoring a couple of green belts. And they do about 4 Six Sigma projects per year. Then you've got green belts, and they are the ones who utilize statistical methods. They've also been trained in statistics and so on and so forth. They also understand CTQs and so on. They also do consulting because there are other people who are none of these three, and they are in the company, and they are the ones that the green belt people work with. They try to make sure that the language is understood and so on and so forth. That's like something that's got to be done by these green belt people. And they will probably try to get some new green belts, and they will probably find one new green belt in a year. That's like something they would like to be able to do. And they complete generally 2 Six Sigma projects per year. That's like the thing. So you've got, I'll say, minnows there, then you've got the trouts there, then you've got the huge ones, the whales there. They are the ones. If you actually see their competence, probably the master black belts, they are the real gurus. They are the real gurus in the company. Assuring results. What are the things you require to be able to assure results in Six Sigma? First of all, you must launch the Six Sigma project as a DMAIC project. And this is something I'm going to explain in a minute. You should have an expert who is dedicated to help you. And he's the one who should have focus on your bottom line. That means the gains of the project. He must have a very clear focus on that. He should be striving to deliver those financial things. He must, do all the metrics and measurements and everything else. But this is the expert who really can see the link between quality, the process, and the ROI, the potential ROI of the project itself. These are generally people who are master black belt holders. You must define the roles of the team members right in the beginning. This is something that's also required to succeed with Six Sigma projects. And success will depend very much on the roles and responsibilities, and also making sure that the tools and techniques are all put to use. This is something that has got to be done. So you may have people that are well trained, but you must also bring along the tools and techniques, and you must combine the two to be able to exploit this new approach. Let's take a look at a Six Sigma project. Let's take a look at a Six Sigma project. How does it go? A Six Sigma project, every Six Sigma initiative has got to be launched as a project. And let's take a look at this project. This project, it's got a define phase, then you've got a measure phase, then you've got an analyze phase, then you've got a control phase. And they are there just like a regular planning project. I define the project, I measure the quality characteristics as they are, then I plan the analysis and improvement steps. My design of excellence will be going on there. Once that is complete, I get the optimum settings of the process. Those are controlled there. Down below, I list the various things that get into defining the project. The goals, the specs, the feasibility, the tasks, the responsibilities, and the teams. All this is to be done right here as you're kicking off the project. Then, of course, in the planning phase, you'll be doing some measurements. So you get the direction. You'll be working on the schedule for various things, the budgets, resources required, any risks involved, and staffing. All those things you'd sort out here so that your execution goes on nicely. And the execution would then involve generating status reports. Are the improvements the way that you have projected them to be, or do you need some corrections there? Obviously, measurement of quality that is there, and so on and so forth. These would be done at the analysis phase and the improvements phase. Design of experiments, DOE, would be done at this stage. Once this is done, of course, you got to bring in the client or the customer. You got to train him. You got to write some documents. You got to make sure you set up the new process control, shall I say, protocol. That also would have to be there. You will perhaps reassign the project team to some other project there, and will document the lessons learned from this effort. That's also something that you'd like to be able to do. Now, what happens when you take a Three Sigma project and take it to a Six Sigma project? I'm beginning with a Three Sigma project, and just see what happens when I shrink this project, shrink this process. Did you see what happened? Let me do it again. I start with a process that's a Three Sigma process. The distance between the target here, the midpoint, and the spec limit is 3 sigma this way and 3 sigma that way. Because this curve is pretty flat. It's got a high standard deviation. Mean is at 8, but the standard deviation is 2. Look what happens when I shrink this to a 4 sigma process. Now, by shrinking, I mean the sigma metric has gone up, but standard deviation came down from 2 to 1.3, and now I've got most of the process confined between minus 4 sigma and plus 4 sigma as far as the midpoint is concerned. I've got it reduced there. This is a 5 sigma process. You can actually see it's got tightened further, and this is a 6 sigma process. It's got tightened even more. So again, going back by the pictures, this will go almost like a movie. Now I've got a 6 sigma process there. What are the results? What are the benefits of 6 sigma? Well, for one thing, you're going to be improving CPK. Remember CPK. CPK is the process capability measure for a process. How capable you are of satisfying your customer from your routine production. That probability is actually low when it comes to 100% satisfaction of the customer, when you got a process which is like perhaps a 3 sigma process. But as you move toward higher and higher sigma metric number, sigma metric, I'm not talking about sigma. Actual standard deviation is reducing, but the sigma metric is going up. This is something you got to know, you got to remember. When I do a 6 sigma project, I'm reducing standard deviation, but I'm increasing what we call the sigma metric of the process. So it goes up from 3 sigma metric to 4 sigma metric to 5 sigma metric to 6 sigma metric. This is what is happening, and in the process is getting tighter and tighter and tighter and tighter. So the green one here is a pretty tight process that's got a high sigma metric value, and the red one, of course, is a poor process. It's got a low sigma metric value. So a 3 sigma process actually will have part of the tail actually beyond what we call the spec limits, and the 6 sigma process will have almost nothing beyond what we call the 3 sigma limit. In fact, there will be nothing. In fact, it could only be a few parts per million defects that will go beyond what we call the specification limit. That's like one of the advantages of going from a 3 sigma process to a 6 sigma process. This is like another way to show the same thing. I have off-spec material beyond this and beyond this. These are my spec limits, the upper spec limit and the lower spec limit. A 3 sigma process just fits in. It just fits in inside that limits set by the upper and lower spec limits. So the black curve just fits in. This black curve is going to give you defects in percents. Compare that to the blue curve. The blue curve is a 6 sigma process. It will actually have a tiny amount, this blue tail going beyond it, but that will be at the level of parts per million. So in fact, a 3 sigma process will have off specs at percent level, and a 6 sigma process will deliver material that will really be off spec at parts per million level. That's a pretty good level of quality. That's pretty good level of quality. So again, I've given you some other details of what is the impact of going to 6 sigma. Now notice something I had told you quite some time back, that the best place to be in terms of delivering products to a customer is to try to identify what the target performance is that he's looking for. What is my target shirt size, for example? And I'd like to sort of make sure that I get my size 42. If that's my size, that's the shirt I would like to get. I would not like to get a 39, 40, 41 or 43, 44, 45. I'll be the happiest man when I get a size 42 shirt. What happens here is, because your process is already so tight, you can allow that average to be floating around a little bit. And let me show you that in a picture. I have this black process here is a Six Sigma process, and the spec limits are far out here and they are far out here. You notice here the off specs are over here and the off specs are over here. So even if this black curve shifts a little bit, it goes up and down by what we call 1.5 standard deviation level. If it does that, I will still have almost nothing going beyond the spec limits on this side or the spec limits on that side. And that's why if a process is truly Six Sigma, if it is operating at a level of plus minus, if it is at Six Sigma level, you can allow the average to vary as far as that process is concerned by plus 1.5 sigma and minus 1.5 sigma. You still maintain that high level of customer satisfaction. Because even if I move that black curve to the left or to the right, I'm not really producing any significant amount of defects, because my control limit, my specification limits, they are pretty far away. I really have no danger to get into that area there. That's like something that again I gain when I come down to Six Sigma. Evolution of Six Sigma, how did it actually evolve? Well, if you look at Japan, Japan contributed many things in the movement of quality, in trying to improve quality. They gave us parts of TQM. A lot of TQM tools came from Japan. They gave us Kanban, they gave us Kaizen, and many other things, QFD and so on and so forth. Those, and even the latest Kano model, it has also come from Japan. So the Japanese have been contributing a lot of things. By contrast, the Six Sigma movement and the Six Sigma method has come from the US. And it was pioneered in the US by Bill Smith of Motorola in 1986. And from that point onward, because it was a superior level of quality, many companies, they tried to move towards Six Sigma. And of course, the attempt there was to apply statistical methods to try to understand this cause and effect relationship. Once that is understood, it's not going to be very difficult for you to tighten the process. Once you know what are the factors that cause a high sigma, a high level of standard deviation, and then adjust those things to try to make sure that that standard deviation of the process reduces and you end up with the Six Sigma level of performance. Early adopters of Six Sigma, they were Bank America, Caterpillar, Honeywell, and a number of other people. And GE became a pretty big champion of Six Sigma. If you keep looking at the method itself, what are the methods? And the first and foremost is, of course, the DMAIC methodology. So I'm going to again write that down for you. DMAIC, D-M-A-I-C, DMAIC. DMAIC stands for define, measure, analyze, improve, and control. You got to go through these five steps to be able to achieve this Six Sigma level of performance. So it really relies very heavily on statistical methods, and some are pretty advanced methods, and you got to get some training in this area. It's a new way for doing business. It's a new way to deal with your customers and so on and so forth. And in almost all cases, it eliminates a lot of defects which might be there. The steps of this are, of course, again, I'm going to be walking you through some of the steps. Choose the improvement projects very carefully. That's something you've got to be able to do. These are not just the low-hanging fruits, but also problems. In fact, persistent problems are chronic problems. These are the ones you've got to be able to target. You got to also make sure that you produce an ROI, a potential ROI, a possible ROI that might materialize if I tackle this issue. If you tackle something that does not produce any ROI, it's going to be tough to get management support for it, because you need a lot of resources to be able to walk through to be able to execute the Six Sigma project. That's why it's very important that you identify the financial incentives for doing this. Then, of course, you should be applying the DMAIC procedure. And I'm going to be again walking you through the steps of DMAIC, so it will be a reminder for you. And of course, the whole process is going to be data driven. You'll be making a lot of measurements, a lot of approaches, and so a lot of data collection and analysis and so on. Those would also follow through as you walk through the DMAIC process. So the very first thing is you'll define the project, the goals of those projects, and the deliverables to the customer. This is something you're going to define. There may be an issue there. There may be a quality issue there. Some CTQs may not be being looked after. That's something you've got to be able to do. You must measure the current process. This is the second step of DMAIC. You must measure the current process performance. This could really be measuring the number of defects you're producing or CPK, any of those things, and find out precisely which CTQ is leading to those things there. Then you do the analysis. You try to do some root cause analysis. You try to sort of find out. And this would be involving some techniques, some mapping and process mapping and so on. I'm going to illustrate that with a case that we have for you today. Then of course, the next step is improve. Now that I've done the analysis, I've identified the factors that might be causing this high level of defect. To be able to reduce them, I've got to apply some special methods such as design of experiments. That's something personally, by the way, I'm very, very fond of design of experiments. That's something I've succeeded with many times. In my lifetime, in my professional career, I've probably conducted 35, 40 different design experiments. And these have had applications in widely different areas. In biotechnology, in genetic algorithms, in mechanical production, in chemical processes, in metallurgical processes, all kinds of processes I've tried to apply DOE, even in some qualitative areas when you basically look at qualitative results to come out. Even there I've found DOE method to be a pretty decent framework to apply, to utilize. Then of course the last step is in DMAIC is going to be, once I've located the optimum settings for these different process control factors, I've got to keep them there. I've got to control them to be there. And there, of course, only then my process is going to be stabilized at that point there. I must have sustainable improvement. I must have improvement that will continue after I walk away from the process and I set them at the right levels there. I set them at the optimum levels there and I walk away from it. My process control system should be able to keep it there, should be able to keep that process there. This is something I should be able to do. Now, I've given you a bunch of slides there. These actually also amplify the define, measure, analyze, improve, and control steps. For example, there is the issue of benchmarks, baselines, customer requirements, customer commitments, and mapping of the process flow. Then, of course, defect measurement, data collection process, collection of data, creating of certain forms on which you collect the data, and then compilation and display of the data itself. Then you've got verification of the data itself, then drawing some conclusions from it, and setting up some tests, determining improvement opportunities. These are all going to be there, determining the root causes, identifying those factors that might be there. Then again, mapping the causes to effects. That's like something I need now. Then I move into the improvement phase where I create the improvement ideas. I create models. These could be process input response type of model, y equal to fx type of model there. I set some goals. I create the problem statement. Then I create the solution statement. Then this is the step that goes through DOE, design of experiments. Once I got the improvement there, once I got the improvements achieved, I demonstrate that it is there. Once I have the optimum levels of these different factors identified at the improvement step, I move into control, but I try to keep, I monitor the improved process and I try to make sure that I maintain the process control variables at the levels at which they are optimal, so that I maintain sustainability. That's something that is done by the Six Sigma process itself. To give you a few more details on the defined process itself, it's going to be very important for you to identify important quality problems. Don't just look at the low return projects. They're not going to have much kind of a following in the company. Even if you come up with a great improvement for a very tiny problem that was there, no one was concerned about it, it's not going to, you might put a lot of effort and resources to try to improve that. Please find a problem that's an important problem for the company. And there may be 2, 3, 4 of them, and you could do a little Pareto to try to understand what really is there. Select a project to combat 1 or 2 of these big problems there, and define the relevant parameters, and these would be normally defined using those CTQs as % defects as they prevail today. And you'll be looking at some input factors, and this is something where you could produce an initial list. Then of course you'll be going to measuring the CTQs. That's something you'd like to be able to do. This is like you're measuring the process as it exists today. You also should measure CPK, process capability. How capable is the process as it is today? Is it near 1? Is it below 1? Is CPK below 1? Then of course it needs a lot of improvement. Is it like 1.3 or 1.4? Then of course it would need some improvement. If it is near 1.6, it might need a bit of nudging to move it to 2. and CP equal to 2 is the level where you've got Six Sigma quality. So that's like something, if you got a reading of CPK on your process, you pretty well you can probably say at what sigma metric level my process is operating. So this is to be done at the measure phase. Then you've got the analysis phase where you probably be using the fishbone diagram. I find the fishbone diagram extremely handy. If I can remind you of what that fishbone diagram is, the effect is at the end, and then I've got various causes. These causes are A, B, C, D, and perhaps even noise factors. Perhaps there will be some noise factors also that would be disturbing the process. I may have some noise factors also, N1 and N2. This diagram is the fishbone diagram. It's a brainstorming tool. You in fact bring together people who are going to be interested. They are knowledgeable about the process, and they might have a contribution in terms of identifying or listing one or two of these factors that should then be further investigated. That's something that is done in the analysis phase. So this is the place where you might do either you do brainstorming, or somehow you construct this list of these factors that are going to be utilized then later on in the thing. You could also do, at the analysis phase, you could also do this engineering analysis study called FMEA, failure mode and effect analysis. This is also something that is very, very handy. If you do FMEA, you're going to be winning, because it's going to identify all those factors that could have something going wrong with them. Then of course you've got the DOE phase, which is the improve phase. There you try to discover the relationship between y is the response, and x is basically the various control factors. So x here in this case is going to be x1 is here, x2 is here, x3 is here, x4 is here, and y is sitting right here. So y I will put down here, y is here. I've got x1 as one of the factors, x2 here, x3 here, x4 here. These are going to be the control factors, the experimental factors. My goal is going to be to study the effect of x, the various x's on y. I'm going to be studying that empirically. And this is to be done using what we call the design of experiments, the DOE framework, as I show on the slide there. This slide shows you where DOE comes in. DOE is generally used to try to find the potential causes and see whether or not they have an effect on y. So it'd be involving many different x's in your DOE step to try to sort of see which of these things are important and which are the ones that need to be controlled, need to be adjusted in order for us to achieve an improvement there. Once I've achieved the optimum settings for these control factors, I will be setting them at their optimum level. So the x1, x2, x3, x4 that I've identified so far, perhaps identified only 3 of these factors that have become important. So I've identified x2, x3 and x4. Perhaps these are the ones that are the important ones that have the largest impact on this. And this one probably does not have much of an impact. I need a process control setting for this, I need a process control setting for this, and I need a process control setting for this. This would be done when I come to this step called control. See that slide there? It says control phase, and it says now determine your ability to control these vital x's. Now that I've identified them, I should have the means to control them. This will be done when I've actually focused. I've come down to this level of process control. So DMAIC is now a step-by-step process. It's a discipline that defines, measures, analyzes, improves, and controls a process that currently producing defective goods. DMAIC unlocks the true sigma success for a business, and it does that by cutting defects, raising customer satisfaction, by cutting down losses. This is something that has to be done. Unless this is done, of course, you are not going to be moving up the ladder of quality assurance. I'm going to continue in a few minutes and just wait for the next session to begin. Thank you.